Welcome to today's tutorial. We'll be going through practical 7, right? Which was a bit of, since it's a new topic and they were introducing something new, string manipulation, right? How to work with strings. So therefore, it was a bit tricky, but in order for us to understand this trick, we need to understand sort of like everything that goes into place, the registers and everything. So what I'm going to do, okay, I already have it open. I'm going to go to resources and download the Mesm folder, right? So I need that Mesm folder. And then there it is, it's loading. It's downloading. Okay, done. And then I'm gonna close, and then I'm gonna open the folder. So I'm going to extract all. Okay, it's quite a big file. Not too big, but it's quite big. Okay, so there it is. I'm gonna open VS Codium. So why am I using VS Codium? Because it disables a lot of the what's this thing? A lot of the what are they called? Telemetry features, right? Meaning that it disables any tracking because with the normal Visual Studio, it tracks your activities and things like that. That's why I use VS Codium. So okay, I don't see close. Okay, it doesn't want me to close. So let me say open folder because I wanted to close so that it shows that welcome page. And then I'm going to open the Mesm folder. Okay, and then I'm going to double click on my assembly folder. And then always remove the information at the top and then put in into your details, right? And then remember everything that's data, meaning your variables. Anything that involves you putting a data type, whatever, that's your data, right, for your application. So you're gonna put it under there. And then under code, that's where you put your actual code, meaning functions. That's the code section. So they even wrote comments there, so they helped you. And then what I'm going to do is I'm going to create the function, right? So let's start. For you guys, it's simple. You don't have to work with what is this, local variables and things like that, and do all of and also pass parameters to the function. Like you don't have to do all of that. You just work with global variables. So it's easy. You just need two arrays, if I'm not mistaken. Yeah, you need two arrays. One array to store the actual characters from the user, and then the second array to store the reversed string, right? So let's declare the variables. So they say you can use any registers, right, that are relevant. Remember, that are relevant. And then I'm going to, for the character replacement, create two variables, search char and replace char. So let's do everything as we follow, as we go. So I'm going to highlight this so that you see that it says create global variables only. That means you do not use local variables and you also do not pass parameters. They said only global variables. It's strictly that. So they say create two variables, right? Search char and replace char. So this search char will hold the character to be searched. So let me create the variables. You realize that you face issues when trying to declare this variable exactly as it is. Why? Because there's a function called input str. So this one I'm not gonna declare it like this. I'm gonna write it in full. If you did try to declare that, you should have faced that error. So for the character replacement, create two variables, search char and replace char. They will hold the character. Mm, duh. So it will hold the character. And if you remember you remember what we talked about arrays and things like that, or data types, whatever. Remember byte. Let me change the language to assembly so that it highlights that it's assembly. So remember byte, it basically means 8 bits. Or bits, in short, it's binary digits. If you remove some letters in these two words, binary digits, you'll find that you get the word bits. So if I delete this, you see that it's bits. So bits is short for binary digits. And those binary digits is just basically zeros and ones. Remember, your computer uses transistors, which is like a switch, an on and off switch. We use zero to represent an off state. So zero means that the switch is off. Yeah, I know like people like to fast forward when they get to this part of the video, and that's probably why you're failing. So zero is for the switch to indicate that the switch is off, and then the one is to indicate that the switch is on. So it uses that pattern of zeros and ones. So on, off to sort of like give meaning to information inside the computer. So as you know that there's this thing called ASCII standard, right? Or ASCII table, which basically means that each letter or character, basically every character on your keyboard. We're not referring to characters in languages like Spanish or Italian, whatever. We're not referring to those languages because they have special symbols that might not be found on the keyboard. ASCII specifically stores only the characters on the keyboard. So each letter is is re so each letter, okay, each letter is represented by a specific integer. So each letter is represented by a specific integer. So for example, what do I mean by that? So for example, the capital letter A is represented by the integer number 65. And then small letter A is represented by the integer number 97. So that's pretty much what that means. So if you check the range for each character, the range that each character can store, right? Each character is actually can actually store 1 byte. That's I want you to understand why we do some things so that you understand why. So 1 byte is it actually uses 1 byte ASCII character to should I say that's the range? Yeah, that's the range. It uses byte, right? And a byte, there's two ways you can represent a byte. It can be but you can represent both negative and positive values or only positive values. So by representing both negative and positive, that means it's from the range 128 minus 128 to 127. But if it's only like unsigned, right, or positive range, then it's from 0 to 255. So, and it's inclusive, right? So, which is sort of like if you remember C++, your pixels, they were within this range, right? So the right data type to use in that case would have been a byte. So that's the range for your ASCII values. They're within that range. You can go online and Google. You'll find out that the ASCII table, it has letters or numbers are usually within that range. They don't go beyond. Oh, so it starts at negative. Yeah, you see, it stops at 127. So it starts at negative, but it actually starts at zero because I don't remember using negative values to represent characters. So it starts at zero. So it's actually from 0 to 127. So meaning that it uses this one, but then it doesn't make use of the other parts. But it's fine. It could also use this as unsigned one and not, but since it starts at exactly zero. So it uses, at the end of the day, what I'm trying to say is that it uses the byte data type, meaning the byte range. So that's why if you remember, when we create a string, right? We say, for example, str input byte like this, right? Okay, I've been doing a lot of C++. I hope I still remember. Yeah, you say byte, and then you put in that string, right? So let's say enter your name. Okay, my memory is a bit fast now because I was busy with other languages. So you declare it like this, right? What does this mean? This means that the byte is allocated, each character is allocated the range for a byte, which is true because if you look at the ASCII table, it stops at 127 and it starts at 0. So, and remember, memory is very expensive. We allocate, I know you might be like, well, that's very close. Why didn't they just use maybe an integer? Or, okay, there's byte, then there's what's the other one? Word, yeah, or word, or whatever. Why didn't they use that? Well, remember, byte, it's 8 bits, right? And then word, it's twice, which is 16 bits. And then D word, it's also twice the previous one, which is 16 times 2, which is 32 bits. Then we have a quad word, which is 64 bits, right? So let me put it in terms that you can understand. So this would be the byte type inside Java, and then this will be the short type inside both Java and C++, and then this will be int, or int, right, inside Java and C++, and then this will be long in Java, or in C++ it's called long long. So that's what that means. We're just writing it in the assembly way, which is like the low level way. So a byte, I only need 8 bits, meaning that I only need within this range, right? Or I can use this range, it doesn't matter. As you can see, my range for ASCII value, for ASCII characters does not exceed 127. So therefore, I should allocate a byte for each character, right? For each character. So how can I represent a string now? So what is a string? If a byte is one character, so if h is represented by 1 byte, right, then what will be he? Sum it up. H is 1 byte. This is another byte, so this will be 2 bytes. And then a whole sentence. Let's say, for example, hey, how are you doing? Something like this. You allocate a byte for each character. So 1 byte, 2, 3, 4. And the space is also a character. If you check here, it is there. I think it's 32. Yeah. Integer number 32. So the space counts as a character. So even the spaces, you're going to count them. So you see, you end up realizing that this is an array of what? Bytes. It's an array of bytes because each character is saved under the byte data type. So basically, it's an array of bytes, or it's a collection of bytes. So that's why when we declare our strings, we're going to declare it in this way. Remember how we've been declaring numbers. Again, we said, for example, an array would say array and then D word because it's an array of integers, 32 bits. Integer, then you pass in the length of the array, space, and then we put in this dab to say that this is an array. And then you see, and then that question mark, remember question mark just means that it's not initialized. There's nothing, it's not set to anything. So here you pass the length. Let's say I want an array of 10 values, then I'll do that. So the same, so this array would actually be interpreted in this manner. The computer will view this as like a D word pointer. Basically, it's pointing to a collection of D words or integers, which is the same as remember, think about it in C++. Remember, when you allocate memory on the heap, you say int, and then array is equals to new int, right? Let's say you want 10 values. Isn't this an int pointer? It is, right? But int in C++ in assembly is called dword. So dword pointer. Hence we say dword pointer. So that's the main difference. So when it creating strings, it's pretty much the same thing. I'm going to say input str, right? But then it's byte because each character is allocated a size, a byte size is given a byte size. And then the length here, I don't know how big the sentence will be. So, and they said it can be a paragraph. So you just come up with any random value. Let's say the size is 10,000 characters. And then tab, question mark, um, is not initialized to anything. So now we've created a string array or an array of characters. This translates to basically or byte, right? Remember, byte is also in C++ is also char, right? Byte is the byte range. Remember char is in C++ is remember in C++ there's no byte type, so we use char. So char is the same as a byte. It's 8 bits. So this would technically be a byte pointer, or you can say that's a char pointer, right? So it can either be one of those, however you want to view it. So that's enough of explaining. Now let's start coding. Time really flies, eh? Let me start coding. So we have our code, right? So let's start with our function, right? So before I do that, let me create the variables. They said, let's look at the variables. So search char and replace char. And I must store a character. Remember, we do byte plus dab like this and the size when we have multiple characters. So it's a string. We only want one character. So let's say this would be hex. We just say byte like this. And you can put a question mark to say, remember, everything is null. Every string is null terminated. This null, it'll if you don't understand that now, you're gonna face serious problems. So in order to solve those problems, you need I suggest you go to Google and you to some C course, right? And learn about C strings. Or go to the C++ textbook. They do talk about C strings. So let me show you is it program design. So if you check the where's arrays and strings, they do talk about C strings, right? There it is. So they do talk about C strings. You might be like, well, I'm done with comp sci. Well, you're gonna fail dismally with your practicals. That level of attitude shouldn't even be allowed. Why you feeling yourself like that? Pipe down. Pisses me off when someone says that, yeah, I'm done with comp. Well, that's the reason why you're still failing because you think none of this information that you learned in your first year still applies. Well, it does apply. You see what I'm talking about? It's now terminated. By now, it's simple. It just helps the computer know when to stop reading the strings. Because remember, C is almost like assembly. It's low, it's close to low level. It's still high level, but it's like it's indecisive whether it wants to be low level or high level. It's like at the middle. It's literally at the edge. It can fall on either side. That's C language. You can't really say that it's really high level or low level because it's neither, but it also encompasses both, sort of like C++. plus plus. You can't really say it's fully high level because there's access to low level memory. And you can also say it's not high level because there's you don't use D words and quad words and things like that. So C strings, what's the C string? It's basically, for example, you want to output the string hello. The computer, the way it works, if you're writing strings in C, because you have to do everything on your own. C and C++, they have this philosophy of like, okay, trust the programmer. So it's going to start here reading H, it reads E, it reads L, it reads L, it reads L, O, and then continues reading. It will continue reading even when there's still nothing because you didn't tell it when to stop. So that now there, what it does, it says stop there. So when it sees the null, it's like, oh, I'm done reading my string. And you realize that even with loops, so this is how you create a C string inside in the inside C. You say const char pointer, and then I'm gonna call it C string is equals to this. And then you simply do a while loop. You say while C string, right? Let's say you start Yeah, you do this. You create an integer. Integer is too big. You could use a short, but that's not the purpose of this video. Int I, we started index 0, right? Remember a string is basically an array of characters or a char pointer. So I'm going to pass I here and then say while that's not equals to what? Null. That's basically under the hood, even when you do strings in C++ and Python and Java, it uses C. Remember, all those languages use C under the hood. So they're doing this. This is something that you really need to understand. This now you might be like, yeah, like I'm gonna repeat again. Nothing makes me more sick than a person who says that they don't need to know something. Clearly, that's why your marks are that bad. So you need to understand everything. So that null pointer, it's going to, while that's not equals to that, what do we do? So I'm just going to, okay, so this is C, right? In C, you say printf like this, and then you output that C string I, right? And then let me see. Thing is, I forgot. Mm, oh yeah, it's like this. And then if I'm not mistaken, and then you say, is it percent? Yeah, percent C to say you want to output a character. And then you print that character. And then remember to increment I plus plus to move to the next character. So that means it's going to read H and read E and read L and then read L and then read O. And then it moves on to null point to the null, right? Remember this incrementer will increment and move us to null. Then it's going to check this condition. Oh, it is now equal to null. So I've reached the end of my string. So let me stop. Let me not even display this. So just keep that in mind. So that's how remember that now terminator that it helps us a lot. So let me close this textbook. So search char and replace char. So let's create that. So search char byte because it's a char, right? And it's exactly one character. So I don't know what to initialize, so I'm just gonna put a question mark and then replace char byte question mark null terminator. Now you understand this zero. This zero it means null. It's because strings and any character it's null terminated so that it knows when to stop. If you forget that zero, it's gonna read infinitely, and then that's why your code end up crashing. So you need to understand what you're doing. So the search char will hold the variable to search, blah blah blah. For now, you need to hard code these character values. So they told you to hard code. Hard code means that literally add the values, don't get input from the user. So since I need to hard code, I'm going to say, let's say my string searches for every hash and it replaces that hash with a question mark. That's that's what they mean by hard code. And then I'm going to so for the string reversal, blah blah blah. Okay, let's see this for the string reversal, the user must be prompted. We need to highlight those important keywords, prompted to input a string to provide a string as input. For example, a sentence or a paragraph. And the entered string can be stored in an input str variable. So let's try to declare and the reverse string will be stored in a reversed str variable. You realize that if you try and say input str, okay, before I continue, remember we need to include our function, our header file, include header file, not really header file, it's called a library. Include a library that has the input and output functions. So to include, you write include in uppercase letters like this, followed by the library you want to include. It's called io.inc. They wrote it for you, right? The lecturer implemented it for you to make things easy for you. So input string, right? Byte. Remember, this should be a string. It's an array. So I'm going to say 255 here and then tab question mark like this. So we have the byte array. And then let me show you what I mean that is going to crash. So let me run this. So dot backslash create dot batch. I'm running the batch file on this assembly file. So you see, read definition of input str, because there's a function called input str to get the input, the string from the user. So therefore you can't call it, I don't know why they didn't test that when they were making the PDF, the practical. So it's going to be input string in full. That's how I'm going to declare it to fix that error. Even though they told you to do this, you can't do that. You can't declare it like that. And then reversed str. Reversed str, there's nothing called reversed str. So I'm gonna declare, leave it as it is. Reversed str byte 255 dub, right? And then we have our arrays. That's pretty much all you have to do. Let me see. That's pretty much what you have to do. So what I would do, right, I'll add an extra variable, which is not necessary. So I'll add an extra variable called length, right? So, and remember what I said, yeah, remember what I said, I could use a byte type, but then the byte type, we usually reserve that for strings and arrays, right? I will use a word, meaning a short. I want to save memory, that's why, because I'm only going to store the number 255. So int length, and then I'm going to use a word data type and store the length of the array. That's pretty much what it stores. Stores the length of the array, of both the arrays, right? You could set it to 1,000 because they want a paragraph, but that's fine. I'll just choose 255. I don't know how many paragraphs, uh, how many characters a paragraph would be, but I'm just gonna choose 255. So in the code section, we can now start writing our functions. So you must create 3 functions. The other parts, right? I'm not gonna read because they're irrelevant at this point in time. So you need to create a replace characters function, replace chars. So let me copy the name. Okay, so there's the function, and then proc near 32, and then end p, and then we need to create or set up the stack frame, and then we need to destroy stack frame. So stack frame, just view it as like a piece of memory that you are reserving for this function. So it's like you're saying inside a box, allocate a specific space within the box. So that box will only reserve space for me to work with this function, whether I want to get inputs in the function or process, but that specific section within my box will be reserved only for the purpose of me working with this function. So there's the stack. So I need to start by pushing EBP. So remember EBP register, that's the register we're going to use to work with local variables within our functions and to also refer to to parameters that are passed inside the function, right? And then we need to move ESP into EBP. This is now where we actually set up the stack frame. That's that specific line. And then we push our registers, right? Remember not to push EAX if your function is supposed to return something. And the order that you push it in, right? The order that you push it in is the same, you're gonna do it in reverse when you're popping, because remember how a stack works. It always adds it to the top of the stack. So if I'm pushing this thing in this order, this is what it means. So let me show you what that means. If I push EAX, it's going to push because there's still nothing right inside the register, inside the stack. And then I push EBX, it pushes to the top. I push ECX, it pushes it to the top. I push EDX, it pushes it to the top. So it's actually in this order. So that's why when I delete in that order. Because the stack work, it always appends or adds to the top a new element. So now I'm going to destroy the stack. We're basically doing the opposite. So we started by okay, this is the last thing that we did, right? So I'm gonna start here. So then I'm going to say push FD, right? Push my error flags, And then I'm going to start by popping those error flags, pop FD. So you just do the vice versa of this, push FD, pop FD. And then we start, remember the stack, it always pushes to the top. So remember what I said, it always pushes to the top. I said push FD, so you can imagine that push FD, those error flags are at the top now, right? So I need to start by popping them first or deleting them. So you see, that's why if you look at my code, I said pop FD first. And then after I've popped, that means this is no longer there. What do I pop next? EDX, and then pop ECX, and then pop EBX, and so forth. So let me do that. So pop EDX, and then pop ECX, and then pop EBX, and then pop EAX. And then once you're done, you need to now destroy the stack frame. So how do you destroy it? You move, but remember you moved it in this way. You moved ESP into EBP. Now you do it vice versa. You always do vice versa when you destroy. So now you move EBP into ESP. So I'm going to say move EBP into ESP. And then we had previously pushed EBP. We now need to pop it. So pop EBP. And then we return. So this is the same as like return 0, sort of. But we don't return anything, right? But at this moment, we won't return because we're not taking any parameters, right? You would return the number of bytes that have been used, especially you look at how many parameters you have, sum up the bytes and then return. If it's supposed to really return, at this point in time, it's not returning, so we don't have to worry about that. And then this will be my function body, right? And remember, you don't always need to push it in this order. You can start by pushing EDX, it doesn't really matter. But make sure that same order that you've pushed in is the opposite order when you're deleting. So let's start with our code. How do you replace a character? Okay, before we start with our code, let me explain something. So remember EAX register, right? This is used when working with D-words, right? Meaning something that's of the length 32 bits. And then the EAX register, right? It's split up. Let me use draw.io to demonstrate what I'm talking about. The EAX register is divided into AX register, and then that AX register is also divided and it has an AL register. So device, um, so it's a simple diagram. I just want you to visualize it. So this diagram, you're gonna have EAX register like this, right? So you can imagine this full thing is EAX register, right? So I'm gonna put the text at the top to show you that this is EAX register, right? And then I'm going to increase the size. So this is EAX register. So EAX register is how do I sort of like split it up? Okay, so let me explain it this way. I think it should somewhat make sense now. So EAX register, and then copy, paste. So EAX register, remember I said it's 32 bits, right? So let me just give it a color. And then EAX register has two other registers that are there, right? It has the AX register, and then it has the AL register. All of them have, you see, you remember the E, what the E stands for? It's extended AX. So that means it was previously AX, and then they extended the size of AX. So with that being said, you need to know the differences between them. So let me try to see if what I'm trying to explain is going to work. So AX, remember I said EAX is, let me see, 16 plus, yeah. So I forgot what other memory is there, but then it's not, EAX doesn't just include this. it has this and other bits that are there. Remember, it extended, so it has other bits that are there. So since it extended, so we know EAX is storing for it's used to store D words. AX is used to store words, meaning that it's 16 bits. Any variables that are 16 bits long. And then AX register is used to store something that is of byte size, meaning 8 bits. So you need to really understand what you're doing. Remember, each register is like that. Even EBX, ECX, it's pretty much the same thing. So EBX, it's no longer called AX, it's now BX. This is BL, and so forth. Then ECX, there's CX, CL. All of them are like that. They're divided into multiple sections. Remember, we are working with what? This string array of type what? Byte. So we're gonna use what? Which register? AL. When we are retrieving a character at a time. So let's look at what is required. So replace characters proc called from main proc. This is to perform, right? This function is used to perform the basic character replacement. So it's used to perform basic character replacement. It means that you replaced that character. So you need to search for it first. So how would what's the proposed solution for this in inside C++ or C, right? What's the proposed solution? So search and replace in C or C++. So this is how you would go about doing it. So let's see. So let's say a char, um, let's say char A, and it's that character, right? And then you have char B. That's the character you want to put in that place when to replace. This is this is the character to be replaced, and then in place of that H, you need to put in that question mark. So that's what it means. And then, obviously, when you do all of this, we need to have the actual string, right? C++ string. So str input. Let's say this is our string h ll like this, right? So let's say this is string one to replace. So you need to go through all the characters within the string, right? But then remember, I talked about C strings. We actually do, in order for you to understand this, I'm not going to use a whole class that programmers in C++ wrote for you. We're going to work with the raw characters, right? With like the raw pointers. So that means I have to not forget to put that now pointer there. And then now my code is going to change. I'm going to say while, and then I need to create a counter, right? I need to say int uh, I'm going to call it I is equals to 0. And then I'm going to say while, and then I'm going to index into my str input into my string, right? Remember, strings are basically arrays of characters. And then while it's not equals to null, that means I haven't reached the end, like this. And then while it's not equals to null, then I'm going to do what? Comparison. So compare, okay, I'm so used to C++. So compare. So compare what if I found the correct. So it's a simple if statement. If str, that current index I, right, is equals to what character? A. That's the character I'm looking for. Then do what? Replace. So str input I replaced it with this character B. Okay, there's no semicolon here. I'm so used to C++. This is C++. Yeah, it's fine, semicolon. So once I found the character, replace it. But I need to move to the next character. So you need to move to the next character. So how do I do that? I plus plus. And I'm going to translate it exactly as it is. You see how easy it can be once you understand what you're doing. We already have these variables. Remember, char is byte type inside assembly and Java. You use byte. You say byte, right? So yeah, we have the string. We've called it input string. Remember what we've called it? Input string. So now we're going to go through that string. So let's go through it. But before we go through it, we need to set our counter. Remember ECX register, that's the register we work with to count. Remember arrays are zero index, but remember another very important thing that you need to understand about arrays, right? Okay, we'll get about iterating. We'll get to it when you get there. But what I'm trying to say is that when you're doing a while loop or a loop or whatever, this variable, the counter, it always has an extra value of 1. What do I mean by that? So what's the length of this actual string? What is its actual length? Its actual length, remember we exclude the null pointer. It's 1, 2, 3, 4, 5. So it's actually 5 characters, right? So that means I need to stop at index 4 since arrays are zero indexed. So let me show you, let's see what the value of this would be. So we could just put this in a program since I already, so we could just put this in a program. I know there's people like, yeah, just get to the point. Well, getting to the point is not going to help you in any way. It'll be just you wasting my time. So I do not like this thing of coding and you don't picture it. I can picture it clearly. I have no issues in picturing that. So I'm going to say C strings. Uh, okay, you can work with C strings in C++, right? It's fine. We just work with them in C++. I wanted to write it in C, but we can still work with it in C++. And then I'm just going to sort of like align it. There we go. And then I'm going to build to see if we have no issues here. Oh yeah, this is comments in assembly. So let me remove that. And then str input. What did I do wrong? Oh, it's read only. I make it a const char. Let me make it a char. Const, remember const means that you cannot mutate it. So there it is. We have that. And then I'll show you that the actual length of the string is 5 characters, right? So you see that when I say cout I, it will actually it will actually have the index 5. You might not see the significance of me explaining this, but you'll understand when you start coding. Okay, it's putting an error clearly or whatever. So he doesn't like that. So it's fine. Let's not work with C strings. Let's work with the normal C++ strings because I didn't do anything wrong here. And then I'm gonna remember strings in C++, they append that null pointer for you. You could just leave it like this and work with it. It should work. Let me just run it and see. It should work with no issues and not complain. Yeah, because it appends that null pointer for you. So you see it points at index 5. That's the point I'm trying to make. So when you're reversing the string, that this index, this is very important when when you're reversing the string, that it points to the index after the last index. So we'd have to reduce that number by 1 before we copy the values. You'll see when we get there. So we have our function. So let's move 0 into ECX, right? Which is the same as that part when I said int I is equals to 0. That's what it means there, right? And remember working with global variables, no local variables. Then I want to make a loop, right? So I'll say loop start and then loop underscore end. So I'll create labels for that, right? And then I'm obviously going to, okay, I didn't really need ECX. To be honest, I don't really need it. Okay, yeah, I don't really need it because this is assembly. And then okay, this is not everything that I need to do. I need to load the effective address for my array into EVX register. So it's called input string because that's where the string that's inputted by the user will be stored. It will be stored within this variable. So after getting that string, I've moved it into this, right? I've loaded its address. Basically, load the address of the first element, right? Remember, it uses pointer arithmetic to move on to the next, right? And remember, it's 1 byte. So instead of, I shouldn't add 4 bytes when I'm moving to the next one because we're dealing with a byte array. So I just need to increment by 1 byte, not four, the integer four. So since we have an understanding of that, now let's see how we can work with this. So what do we need to do? I need to compare what my my string at the current index with null, and then make sure I want to loop as long as I'm not equals to null, right? So how do I do that? Remember, in order to compare, right, use compare CMP. I need to move that value for that string into a separate. Oh, you could. Let me see. I'm not sure, but I don't recall it being possible. But let's see. So what am I comparing? I'm comparing my string, which is inside the EBX register. So to index, you put in the brackets. It means go to that index. But then remember, this is a byte pointer, right? And then compare it to what? To that byte value, byte pointer of 0, right? You can just say compare it to 0. Remember, 0 just means null pointer, right? So I'm going to compare it to that. Let me see if this operation is allowed. Yeah, so it's running, it's allowed. I thought maybe I had to move this value into a separate register. So that's fine. Oh, okay, yeah, it's already in a register. That's fine, I get it. So I'm comparing, right? Check if the current element is pointing to null, right? So I'm checking if the current element is pointing to null. And then after I've compared, what should make me, why should I jump, right? I should jump when what? When they are equal. So JE, jump if E is equals. So jump to where? To loop end, to end my loop. Else just continue as usual. Remember, if this is false, it will just continue. It will ignore. So that's fine. So you see what I was talking about, that you actually do not need ECX register. Yeah, you actually don't need it. So you only need the array. You don't need ECX register because I can just check if it's not equals to null. And then I've compared, right? So I'm actually here. So I'm at this point here. I've compared it to now to just check to loop, to do the loop, right? Now I need to compare again to the character that I'm looking for. So let's do that. So compare with the character that you are looking for, which is search string, right? Or search str. So compare that current byte pointer or that current character to what? To search char, the character that I'm looking for. After comparing, then what should happen? I should change it. So I can create a separate label to change if that's true. Because remember, you jump to a label if a certain condition is true. So I'll create the label and call it change char, right? To change that char if it's true. And then I'm just going to say jump if it is equal, right? That means I found that character. Jump to where? To change char, to change that char, or to change that character. Else, remember, if I leave it like this, there's one problem. Remember, if this is false, it just continues reading down. So that means it will read down and still change the char, even when it's not the character that I'm looking for. So what I need to do is, underneath this condition, I need to just say jump. So if this fails, it will go straight to here. So jump to where? To where should I jump if that character is not the one that I'm looking for? I should jump to, I'll create a label and say continue, which means that continue to the next element. So I'll say jump to continue. If it's not equal, remember jump, this JMP just jumps unconditionally. It doesn't check any condition, it just jumps. You just tell it, okay, jump. For example, if someone came to you and said jump, you don't even ask how high, you just jump. No questions asked, right? That's what the jump statement does. It just jumps with no conditions checked. Where we actually check the condition is here. Jump is if it's equal. Jump if what is equal? If that current character is equal to that character that I'm searching for, then jump to equals to change char to actually change the character. And then now let's change the character. How do you change the character? It's simple. You just move byte pointer, move that value into that index. But okay, this is fine, right? But I think it works, right? Remember, this is fine. You can leave it like this. But if you wanted to, remember, I was talking about that register, the AL register. So let's actually work with the AL. I was neglecting the AL. So move into AL, this character. I'm going to move it into the AL register because the AL register is for storing by 1 byte, something that's of 1 byte. And then compare AL or compare whatever is now inside AL, which is just this character, to null. And then I do the same thing here. You see that now I avoid repeating myself. I just say AL. And then I'm going to come here and just say AL register. Move into the AL register. What should I move into the AL register? Okay, not into the AL register, right? Remember, AL register is a register of its own. Now I want to actually change this array itself. So now I'm gonna come here and say byte pointer EBX. Move what character? Replace char, because that's the character that should replace whatever character is there. And then it's fine. I don't need to add other conditions. It's fine. I want it to continue downwards. It's fine. I won't put a jump here no, it's fine. I want it to go down. And then what I need to do, I need to say increment my EBX. Remember what inc in this statement, what it does. It just says EBX plus equals to 1. Why am I adding 1? Because it's 1 byte each character. So I must move by 1 byte to the next character. Why do you always move by 1 byte? Why do we do that? Well, the computer, the way it works, right? It views it in bytes, right? It views this H as at byte 1, at index 1, index 2, index 3, index 4, index 5. But then you can view it in terms of bytes, right? You see this values are increasing by 1, meaning they're increasing by 1 byte. So to move to the next character, I must increase by 1 byte or by the integer number 1. So that's pretty much what we're doing there. So I've increased, but if I just leave it like this, what's going to happen? It's going to move to loop end, which is not what I want to do, right? I don't want it to end. So how do I make sure it doesn't end? I just jump back to my loop start. So jump back up to the top and then continue doing. So now what this would do is it will move to the next character or to the next element. And then we're done. That's how we replace the character. So now let's get the input. That's pretty much what you have to do. There's nothing special to that. Just that I had a lot of explaining to do. So now let's get the input. So how do we get input from the user? So I need to ask the user to enter the string, right? So I need 2 extra variables. I'm gonna call it str input to say that it's gonna store the string for the input that the user is going to enter. Enter string, right? And then remember strings are now terminated, so comma 0. Then str output, the string that will be outputted. So I'm going to say output string. And then we need a new line character, right? We need a new line character. So I'm going to say str new line or line feed, whatever you want to call it. The new line character is integer 10 if I still remember to recall very well. Yeah, it's integer 10. Yeah, that's all you need in this practical. You don't need a lot. This practical is easy. You don't need a lot of stuff. And then let's call the function. How do you call the function? You say invoke in all caps. As you can see here, we called the exit process function. It takes in one parameter, which is a D word or an integer, which is 0. And this is the same as just me saying return 0. And remember in C++, in C, you can actually do the same thing. You can say call exit. What is it called? Okay, I forgot I forgot in what libraries it's stored, but you can actually call this call it there's a constant called exit process. So yeah, exit process if I'm not mistaken, but in C, I think it's in C. So invoke what do I want to invoke? The output str function. And you might ask, where am I getting all these answers? There's the io.inc library that I included, right? Remember, this is how you read these functions. We have output str, right? Which does standard call, right? It's a function. And then, yeah, that's the function. And then you need to output that thing that you want to output. And then the function that's important here, it's this one. You see there's input str. It needs you to pass two parameters. So these things like this is parameters. So this one, it takes in one parameter, which is a D word, but not really a D word. I'm going to output a string, so I'm going to make it a byte. Output in takes in one parameter, which is a D word. And how do you pass the parameter? By putting a comma after the function name. So my function name is output str, and then comma, I pass in the first parameter. So what's the parameter? And remember, this output str, it only takes in one parameter. So this parameter, I need to use the addr command to say that go to the address of that string. So address of which string str input, and then now that string, oh, okay, it's fine. Okay, there's that string. And then now I need to invoke my other function for storing the function, the string that's being stored entered by the user. So it's called input str. It takes in two parameters, one d word, comma, another d word. So it's not, you can pass whatever, but remember it's called input str. That's why we couldn't create a variable called input str. I hope you understand now. So I'm going to pass two parameters, right? What's the first parameter? It's the string that you want to actually store the answer into. So remember, you always say addr to refer to that address for that string, or to pass it by address. I think the way you should view addr str input, right, is the same thing as saying address of str input. That's how you should view it. So you always need to pass the address of the string. So what's called input string? That's what it's called. So that's where we should store the string input string, comma, we pass another parameter. What's the second parameter? Now we're passing the second parameter. What's the second parameter? It's the length of the string. So I've already stored the length into a variable called int length. You could type it like this, but you see this thing of putting numbers like this, we call this magic numbers, meaning that in the future, when you look at this number, you'll be like, where did this number come from? This is like magic. It came out from nowhere. Hence, we don't do that. We create variables. So I'm going to say int length or array length. Array length was a better term for it. And then after I've done getting the input, just to check if I did receive the input, I'm going to say invoke output str, and then addr, and then which thing I'm outputting, it's input string. So I'm going to run it again. Let's test now we haven't called the method to replace the char yet, right? Invalid operations, instruction operands. 51. What did I do wrong? 51. Okay, it's not down there, it's up there. Oh yeah. So you can't move the character directly into that memory address. It wants you to do this. Remember, we've already stored that character inside the AL register. So what I can do, right? I know it's sort of like going vice versa. I move into AL the replace char first. Then I take from the AL register that replace char and put it inside my array, because it needs to work with actual what is registers. That's assembly. You need to do it in that way. So now it's running. So enter the string. So let's enter that string hello, LL, and then hash, and then enter. And then as you can see, there's the string. We did get the string. It is being displayed. So we are getting the string. So that's fine. We've received the string. Now let's call the function. And remember, the function is not supposed to pass in any parameter. So I'm not supposed to say push that array. Nah, I'm not supposed to do that. So what I'm going to do is I'm going to just call the function. So call. So let me do this and say call replace chars function to replace my characters. And then I'm going to, and it's literally, that's the nice thing about the the developers who make this thing. What am I doing? I'm calling the function. So call replace characters function. So after I've called this function, this input string would have been changed. So therefore now I can output that string. So what I'm going to do is I'm going to say invoke output str that string. But then I do not want to output that string, right? I want to output the text that says output string. But before I do that, I need to output a new line character to make it pretty. So I'm going to say str new line and then invoke output straddr. And then now I can output that string str output. I've called it output. And then now I can invoke that output str function again to output this new string, which is called input string, to see that if it did replace. And you see that it does replace because logically I did follow everything. So HLL, H, and then as you can see, there's the characters, right? So let me magnify it. So as you can see, the characters, remember we said we must replace every hash with the question mark, and it did replace, but you see it's not pretty, right? I need to add two new end of line characters. So let me add those two end of line characters. So I'm going to copy this since it's the same code. After I've displayed, output that line twice. And then Control Shift, and then I must delete one terminal because now there's two terminals running. And then let's output that same string again. So there's the output string. You see, it is replacing the characters. And then now we need to define another function called reverse string, right? To reverse the string. So the formula is pretty easy. It's not too bad. So let me see how far. Yeah. You guys, I'm tired of splitting videos. I feel like it's not making a difference. If you're really serious about watching the video, you will watch it. So I'm not gonna split videos and divide it into multiple parts. So reverse string proc, right? So it's called reverse string. So I need to create it, reverse string. And then I'm gonna come here. So I need to do this, right? I need to say, just add comments just for the sake of it. Um, replace characters function, right? Just to add those comments, just to make it a bit pretty. And then there we go. And function. Yeah. Yeah. So there's the reverse string and then proc near 32 reverse string and p. And then I'm going to just say end function definition, right? Okay, so there we go. And then this will be my, what is this? My reverse string function. So reverse string function. So there's the reverse string function. And then now I'm just going to pretty much do the same thing that I did on the push my EVP register, set up the stack frame, ESP, And then I push. Remember, I can push it in what order you want to push it in. Let me show you that it does work. But remember your order. You push it, you pop in the reverse order because that's how the stack works. So EDX, ECX, push EBX, push EAX, and then push your error flags, and then pop your error flags. And then now, like I said, it's in the opposite order. So now I need to pop EAX, right? And then pop EBX, and then pop ECX, and then pop EDX, and then move EBX into ESP, and then pop EBP, and then return or move out of the function, right? So this is me destroying the stack frame, and then this is me allocating or creating the stack frame, right? And then this will be the function body. So how do we reverse the string? The formula is simple. In assembly, the way we have to do it, right? Even in C++, we can do it in that way. You typically have strings like this. So let's say I have string A, right? And then I initialize it to hello, right? To hello. And then I have string B, which is going to be an empty string when we start, right? It basically is nothing. Then what I can do is I can do a for loop and go through each of the characters, right? What I can do, right, is this. Let me show you a trick. So the trick is what I can do is I can go iterate throughout the string and and make sure I need to create the counter on the outside. That's the important part. Int counter is equals to 0. I create that count on the outside and then I use the counter. So remember, since this first part is unnecessary, this part of saying int I is equal, I've already initialized the outside. I'm gonna leave that part empty. I'll just continue checking the other parts and say while a is less than a dot, is it dot size? I think there's a size function or length function if I'm not mistaken. A plus no, not a, not yeah, a plus, not a plus plus, counter plus plus, counter plus plus. It's either the length function. So let me just test it out. I think it's been a while since I've worked with strings like that. I'm usually working with pointers and things like that. Strings, let me just output. But I remember there is this size function, yeah. So I can use the size function. It's also there in the vector class, so that's how I remember. So it's 5 characters. So it's 1, 2, 3, 4, 5. Right? It's 5 characters. There's many ways you can go about solving the problem. This is the one of the ways. I'll show you the other way. So yeah, so you have this, you have the function, you have the for loop, right? And then I'll just leave it empty. So it'll be, yeah, just leave it empty. Why am I leaving it empty? Because I just want counter to point to the last index. And then I do another for loop that starts at that last index. And then it decrements moving in the opposite direction. So it's gonna start here, move into L, move into L, move into E, move into H. So this is the first approach. I'm only realizing now that there is another approach that's better. So the second approach, this is the first approach. So now I'm going to check my counter. While is not equals to what exactly? So while is not equals to minus, yeah, -1. Yeah. So while my counter is not equals to -1, and then counter minus minus, I'm moving in the opposite direction. But remember what I talked about when I was talking about that important feature that this I would actually pointing to the index be beyond the last index. So after I've executed this for loop, counter will be storing 5. Is there an index 5 in our array? Remember, arrays are 0 index. There's none. So before we do anything, we need to decrease counter by 1 to make it point to the last index. So counter minus minus before we even start the loop, because it will point to but basically it points to the actual size of this function. You are those who are intelligent enough to realize that this is utterly useless. You can just do it another way. I'll show you the other way. So now my counter variable points to the last index. Now I can use that counter to index into this string A and transfer the values into string B. But then I need to also keep track of string. Okay, so the thing is I need to also set the length for this other string. So what I can do, right? Remember, I think things they should resize automatically. What I can do is I can create another account and call it I, right? Starts at 0. And then I'm going to say while is not equals to -1 and I is less than that other string's size, because they should be the same size, A dot size. And then here you'll also say comma. I'm not sure if you can say comma here. You can say comma there. I'm not sure. Let me say I plus plus, and then let me try to build and run. Yeah, you can put a comma to specify multiple values. Yeah. So I'll make my loop this way, right? And then here, because in C++, yeah, even in assembly, you do the same thing. So we have this, and then I'm going to say my string B, I, is at that current index. Remember, my string starts at index 0, right? And then is equals to my string A at what index? At index counter, because I'm counting in the opposite direction. So I want to go to my string A, use the counter variable, and count in the backwards. So start there, and then decrement, and then move there, and then move there, decrement, keep moving in the opposite direction. But then this string, it moves in the forward direction because it's empty, right? It's an empty string, so I can move in the normal direction. And then I'm going to try to output B now. Hopefully the string does resize. I'm not sure. Let's see if it does resize. It should resize though. Okay, it didn't output. Oh, so yeah, it's not outputting. It seems like it's not. So let me do this. Yeah, but this is the formula. In assembly, it will work. It's gonna resize automatically. So I output a dot size, right? There it is. It's not outputting my string. Clearly, C++ has a different way of doing things, but in assembly, the string will resize automatically. So that same formula is the formula that I'm gonna apply here. So I will use, even they even gave you a sort of like a hint here. They said you can use ESI register, whatever. I will use two registers, right? EBX and ESI. So I'm gonna load effective address and load into EBX my input string, right? The string that I got from the user. Remember that string we've replaced those characters at that point in time, but it's fine. That's the input string. And then load effective address into ESI for my replace str. What is it called? What is it called? Is it called output str or replace? Let me see. Reversed. Yeah, it's called reversed. So reversed str, and then yeah. Oh, I totally forgot another way to do this. So remember, if counter actually points to more than this, that means if I have 5 characters, that means counter will actually be equal to 5, right? Which is the same thing as me calling the size function. So I could have avoided the loop like totally avoided the loop and just set counter to be equals to the size of the string, a dot size. So how do you do this size thing inside assembly? They gave you a hint. They gave you that additional file, right? So to get the size of a string, you just say length of followed by the string that you want to get the length of. Let's say it's input string. And then remember, this will return 5. We don't want 5 because there's no index 5. So I need to subtract 1 so that I get index 4. Now I'm pointing to the last index. So I could have done it in that way and avoided the loop internally totally. So let's do that. So I'm going to what I'm going to do, right? I don't need ECX, remember, because we always look at okay, no, we don't really need ECX. We might need ECX. Yeah, we might need ECX. So let me say ECX and to show that that thing works. I'm going to say let it point to the length of my input string, right? Minus one. You could do that, right? And you see that if I run this, it's going to compile successfully. So let me run it to see it compiles because that's the assembly. You can use the length of keyword to say the length of some string, and you can just subtract a one because this returns the actual length, which is always going to be beyond what we're actually looking for, right? So let me think about how I'm gonna do the structure of the loop. So my ECX register is gonna point to that, right? To the length of the string, which is if it's 5 characters, then it's gonna be 5 characters minus 4, which is really not, yeah, which is not, yeah, I'm gonna do it this way, right? You can structure it in whatever way you wanna do it. I'm gonna get the size of the string and then count backwards, right? So count backwards. So count from 5 to 1. Why 5 to 1? Because I'm assuming, imagine this. Let's say we have a string that's of size 5. If I count from 5 to 1, I actually count eventually all 5 characters, right? So that's my point. That's why I'm doing it that way. So that means I should stop when I get to 0, because when I get to 0, that means I've read all 5 characters. So I'm gonna leave it like this as the actual length. So that's fine. And then I'm gonna say this one, I'm gonna call it for loop and then end loop, right? Remember, I must use different labels than the ones you used before. If you use this one, it's gonna crash. It will say that you've redefined or you're reusing it. And then outside my loop, I'm gonna do a condition, right, to compare. So compare ECX with 0. And then jump when it's equals to 0. When ECX is equals to 0, jump to where? To end loop, to stop my loop. And then obvious, since I'm jumping to stop my loop, I need to decrement that value, right? ECX, I need to update it. So I'm gonna use the loop keyword, which works this way. You say loop, and then it's going to go to ECX register, reduce ECX register by 1, and then go to that to that label that you've told it to go through to. So this will decrement ECX by 1 and then go to for loop label. Okay, I'm feeling parched. Let me drink. Okay, I'm back. So as I said, you use the loop keyword to decrease ECX by 1, and then you point or you go to that label. So it's going to go back to the top. And then it repeats that. And remember, we have a condition outside. So eventually when it gets to 0, exit the loop. And then what do we need to do? So remember what we talked about. We need to point to the current location, right? To the current size of the array. So how do we do that? So what I can do, right? So let me do some simple arithmetic, right? I need to point to the last index. Remember, if you use the register on its own, you're actually referring to the address of that variable. So what I need to do is I need to add into EBX. How many bytes should I add? That's the thing. So I know the bytes because I know the length of the array, which is ECX. But then I want to add ECX bytes minus 1, which is fine. So I'll just add ECX like this. What does this do? The thing is, you guys always be more bitching about my videos being long. So some of the things I might not explain because you guys just like bitching around and saying, yeah, videos are long. So some things I might just totally ignore them and just assume you understand what that means. But for those who actually watch the videos, I'm gonna take the time to explain what I'm trying to do there. So remember when you have pointers, right? So let me teach something about pointers. I don't need to understand pointers. Look at you now. Child by a simple practical. So int pointer num is equals to new int, right? Let's say I have two values. Let me make it simple. Let's say I have two values in my array. Remember when you use the pointer without when you use the pointer name, the variable name without that star, it means you're referring to the address, which is exactly the same thing that we're doing here. So when you use EBX on its own, you're referring to the address. So why am I adding to the address for the size of the array? Why am I doing that? Because there's this thing called pointer arithmetic. So I can say num, let me initialize my arrays. Remember arrays are zero index. So I can say it's equals to 100, and then num at index one is equals to 230. Right? So I have my arrays values initialized. So what happens when you, excuse me, when you create memory on the heap, remember you're using the heap here. Like I always say, the heap is like your grandmother's place, whereby, no, not the heap. The stack is like the your grandmother's place where everything is done for you, everything is managed for you. Then the heap, it's like your parents' place. They tell you go clean your room, go wash the dishes, go do that. You must do everything manually. If you allocate memory, you must deallocate. So what happens is when you create memory on the heap, I suggest go watch that video on C++ on pointers. When you allocate memory on the heap, it creates somewhat of a box, right? A box that's big enough to store two integers. And then within that box, it returns the address of where that box is on the heap memory. When it returns the address, we need to use pointers because pointers are a way of storing the address. So now this pointer array or this array is actually it actually has an address, right? And it's doing what's something called point arithmetic. What is that? It means that it takes the name of the variable, which is the num, and then adds. So when you're indexing like this, when you say num zero, what you're doing is you're saying take num variable, which is the current the address of the first element, add what zero times what the size of the array, which is it's of size 2. So times 2. That's is it the size of the array? Some I forgot the actual formula, but the way I like to view it is like just view it in this sense. Then let's not talk about too much about the size. Let's say you view it in this sense, just num plus 0, right? And then when you say num at index 1, just saying the current that the address of the first element plus 1. So this num variable stores the address of the first element in your collection of arrays, of array values in your array. It points to the first element. Hence, we do pointer arithmetic. So we're adding addresses here. But then remember, this will just return you the address. You still need to dereference. So let's try to see out the information so that you see that it does work. Okay, this might not work the way C++ is very tricky. In C in assembly it works exactly the way I'm telling you. So I need to dereference because I'm adding to the address. So I need to eventually point or go to the address so that I can see the value. And then I'm gonna add an end of line character and then add a semicolon. Let's see if it does work this time. Okay, it is building, so let's try and run it. Yeah, so you see, I can see the values. These aren't these the exact values in my array? They are 110, then 100, and then there's 230. So they are the actual values. So this is what we're doing with pointer arithmetic. So the question is now, how do I point the last element? So since I can get the size of the, okay, I could do this, but it's fine. That's going to complicate things. So I could add the size. I know the size, the length of the array because we store inside a variable, right? Or we can use the length of function to get the length of that array. After getting the length, I say num plus the length, which is going to be 2, right? Let me see if you can call. Okay, you can't. This is not like Java. So I know this array has two numbers, so length plus two, but you realize that you point to a memory that does not exist, you see. Hence it gives you a random value. Why is it doing that? Because arrays are zero index. So the actual last address, it's the size of the array minus one, which is basically plus one. Hence you saw that when I said plus one, it pointed to the last index. So that's why, yeah, I know it took long to explain, but that's what I'm doing here. But then remember ECX, it actually points to the full length. So I need to actually decrement EBX by one so that it actually points to the last element. So when you add the size of the array, this is going to point to the element after the last element. So I need to reduce that by one. So you need to decrement dec. Remember dec just means decrement, which just means EBX minus minus. That's what dec means. So now I'm actually pointing to the last index in my array. Therefore, I can now transfer the values. So let's transfer the values. How do you transfer the values? It's pretty simple. You say, what I'm going to do is I'm going to move my character that's stored inside EBX into AL register. AL register, move it into AL register. And then once I've moved it into AL register, I can now move it into the, yeah, now I can now move it into, what is this? My other array. Remember the other array called reverse string. It's used by ESI register. So move, and then I need to index into ESI register, and then byte pointer, and then I move AL, that value, AL into that register. So now remember it's in reverse order. This points to the end. So I'm going to start storing at the end, but ESI points to the beginning. So you see now it takes the character at the end and moves it to the beginning of the array inside ESI. And then it keeps doing that over and over. But remember, I'm not done yet. If I leave it like this, it's just going to have the same characters, just going to repeat over and over. I'm not moving. Remember, you need to move to remember pointer arithmetic. You need to move to the next index. So I need to add the addresses. I need to add the address. Remember, EBX, it's the address. ESI points to the address. That's why we use LEA or LEA, load effective address. So those registers stores are storing address. So now I need to do what I call pointer arithmetic. So pointer arithmetic. So I need to do pointer arithmetic. How do we do that? So I know EBX register, right? I need to continue decrementing it by one. Why? Because I'm moving in reverse order. But my ESI register, I need to increase it by one because I'm moving forward. And remember, I'm using dec and inc and increment, right? Why? Because I want to add exactly one byte because it's a byte array. And then subtract 1 byte. If you do that other one of saying add EBX 4, you're adding 4 bytes. It's not an integer. It's not a D word. D word is 4 bytes. So know the difference. And there's something that I want to explain. So I'm gonna go back here. Where is it? Where did I talk here? So 8 bits is in other words is called 1 byte, and then 16 is called 2 bytes, right? It's called 2 bytes, and then 32 is called 4 bytes. So when you add 4, you're adding 4 bytes, which is wrong because a byte is exactly 1 byte. So that's why I'm using inc and dec. Because remember what that does, what I've been explaining. Dec just means EBX minus minus. And then inc just means ESI plus plus. I'm adding one. And then that's pretty much all you have to do. But remember, I'm the one constructing the string, the reverse string. Remember this string over here. Let me tell you something important. Remember this string str input, right? This string str input. we got it from the user. So we invoked a function. You can safely assume that this function that we invoked called input str, it appends that now terminate or that now at the end to terminate the string. So that's why we didn't have to worry about whether we put the null at the end or not. Since we are the ones constructing this reverse string, which is inside ESI, that means I need to add, what is this? A null point at the end. But remember what I've been talking about. When you increase here, let me look for the code. Yeah. Remember what I said, at the end of the day, when the loop ends, I is actually pointing to the element after the last index of your string. So that means it's actually pointing to null pointer. Or it's not pointing to null pointer. We haven't inserted it yet, but it will eventually point to null pointer. So if your string is of length 5, okay, this one is of length 1, 2, 3, 4, 5, 6. It's actually 6, but the actual string is length 5. That sixth place or that fifth place. So remember, array is a 0 index, so it's going to be 0, 1, 2, 3, 4, 5, 6. So the now pointer will be at index 6, right? But then if you look at our array, does the index 6 point to something that it actually exists? Nope, it doesn't. But as I was explaining, it will point to our actual array, our actual string stops at index 5. But I will be pointing at index 6, which is the index after the last character in our string. So since we now know that ESI points to, I agree we're gonna keep incrementing it. It now points to the index after the last character. Now we need to do not forget to null terminate your string. To terminate your string by null. How do you do that? It's simple. You just move byte pointer into EBX. You just move 0 into EBX. If you want it to be fancy, you can say this is also a byte pointer like this. Either way, it's gonna work. You can say move 0 or move byte pointer 0. So now, not EBX, my bad. It's the wrong string. It's ESI. EBX, remember EBX register stores the input string. ESI register stores the reversed string. The reverse string is we are the ones constructing it. So therefore I need to now terminate it at the end. And then that's pretty much all you have to do. That's the formula. That's pretty much all you have to do. The thing is, it's a lot of understanding involved. That's why it took time. So after replacing the characters, I'm going to call. So I'm going to call. Is it replace or reverse string method, right? It's literally called call. So you're gonna use the call keyword. So call reverse string, and then it reverses the string. So the new string will be stored inside reverse string, right? So I need to say reverse str, and then now my string will be it'll have both. It will be reversed and replaces the characters. So just starting with a simple string like this. Okay, something is not right. Yeah, something is not right. So that means there's a flaw in our logic. Let me double check. So reverse string, str, yeah, and I did call reverse string. So let me just double check in my code. What am I missing? Mm, but this should work. This part byte pointer, that shouldn't be an issue. So let me just double check. So EBX, we load EBX 0 into, we load the effective address or the address of the first character inside the input string. And then we do the same thing inside ESI. And then ECX stores the length of the string. And then we put a condition here to check. Everything looks pretty fine to me here. So let me just double check. So we're starting at the last index, and then we move into this. Let me double check something here. And then pop EBP. We do get the input string. So output str output. And then output the string, the reverse string. Yeah. Everything is fine. So, okay, but the byte pointer part is not a problem. Let me just literally append the 0 character, but it doesn't really make any difference. Yeah, it really doesn't make any difference. Reverse str, right? So reverse str and then move 0 into ECX. And then blah, blah, blah. Okay, and then ECX. Yeah, this is fine. We just add into ECX the address, the length, so now it's going to point to the number after the last index, which is null pointer, which is not what we want to point to. Then we decrement to move back to the actual last index, which is fine. And then we move the current character into AL register. And then we move from AL register and put it inside ESI register. And then I decrement my EBX register, right? Because I'm moving backwards. So I need to keep decrementing to move from the end to the beginning. And then increment my ESI register because I'm moving forward. Yeah, there's literally nothing wrong here that I'm aware of. Everything looks fine. But let's try to decipher it. The loop is running. Let me do this. Let me put the comparison within, but the comparison should be outside. It doesn't really matter. At this point, I'm just testing out all my theories to see what the issue is. So this age, yeah, that's not the issue. It is running. That's that's really not an issue. So I have that, and then I set it to now point at the end. Everything is fine here as far as I'm concerned. Uh, so move AL. What am I missing here? Yeah, we do store the length of the string. That's fine. You can double check, but the length of the string should be fine. But then I'm just testing out everything now. Length is fine that I know. So output ECX. So we should see the length of the string somewhere. I didn't format it properly, but yeah, okay, there it is, 255. The actual length is 255. Oh, so it doesn't. Hmm. So we could have just put in the length of that string. Remember, we stored it inside a variable called int length. I could have just used that int length. So jump when it's equals to 0 to that loop. So the issue might be here, but okay, I don't think so. So let me say invoke output int, and then what am I output? I'm outputting EBX, right? So I'm going to output EBX before and after. And then invoke output str. I want to output an end of line character so that it shows on a new line. And then I'm going to output after I've incremented. So you see that the address would have increased by that length of the string, right? So let's say my length is 5, right? So it was 5. Let me see. It was 1, 2, 3, 4, 5. So we added 5 there, which was 7. Then we reduced by 1. There it is. So the addresses are fine. There's clearly some small issue. Yeah, because I know this. I know what is this? When you're working with the string yourself, you have to append that now at the end. So that now question, that now part, this one, that appended is fine. And then loop here for loop, I do decrease ECX. So ECX is indeed changed. So decrement dbx and then increment. In whatever order you do it, doesn't really matter. So what's the issue? So is the issue actually there when you're transferring the values? Yeah, so the main issue I think is here. But then this part is fine. And here when I'm calculating the end of the array, it's fine. So this part here is fine also. So these are the two parts that are giving me problems. So I take the current value inside EBX register, then I put it inside AL register. And then AL, let me see. Uh, so mm, yeah, this should work. You're just moving that character A into here. That's pretty much it. I guess assembly is unpredictable. Let me just double check something here. So I call output str function, and then EBX, blah, blah, blah. Okay. Now everything is fine. So let's try to figure out this small error that I made. Where? Because everything looks perfect. If only there was a print char function. There's no function to print a caret. But then, okay, I think I can use the function to print a string, but I'm gonna say the length is 1. Let me do that. ADDRAL, or just AL. Let's see if I know it's something that you've never done. I've also never done it before. I'm just testing it out. Too many arguments to, oh, it's output. It's output string, it's not input. I'm not getting input. Okay, it doesn't crash. So yeah, I thought so. Mm, okay, so what could I be missing here? So move the value into AL register. I'm really failing to understand what's the issue here. I move the value into from EBX, which currently points to the last index, right? Into AL register, and then that value I take it from the AL register and then I put it into the ESI register, which currently points to the index of the first character. So yeah, it should, hypothetically speaking, work. So decrease EBX and then increment ESI. Okay. Okay, so I'm gonna move a so I'm gonna move and then decrement EBX, blah blah blah. So I'm gonna have AL register and then you move, okay, so you take EBX and then you put it aside. And then ESI, you take AL from AL You put it inside ESI register, and then you decrement EBX to move towards the beginning, to move to the character before that. So let me see, am I moving properly? So yeah, I am moving properly because if you look at the chart, right, you see, I started index 4, I decreased that current, so I move to 3. I decrease 3, I move to 2. I decrease 2, I move to 1. I decrease 1, I move to 0. So that part is solved. We have that right. So let me just do this. Let me see if it would complain if I do. Would it complain if I do this? Obviously, I think it might complain because it wants you to transfer it into the register first. Yeah. So it forces you to work with with the register first. It's the same thing, but it wants you to transfer into from EBX to AL register. Mm, okay, this is tricky. So I transfer. This is weird. Why is not? Because I do append a null point at the end here. Oh, I think the calculations, yeah. I think I'm somewhat right, I guess. So let's see. So the condition is that when ECX is 0, exit the loop. So it's going to execute, it already checked the condition, it's fine, it executes, and then decrements ECX and then checks the condition. So technically speaking, I think ESI will be pointing to the actual last index. So I need to increase it by 1 again to move to the index after that last index before I put in the pointer, the 0, the null pointer. That's what I'm assuming is going on here. So let me just do that. Okay, that's not the issue. I thought that was it. So if that's not the issue, that means okay, that means it does. Okay, so let me see. So when ECX is equals to 0, right? So it's gonna go here. Let's say I'm at index 5. I'm at the last. I've inserted the last value, right? The last. Oh yeah, I need. Yeah, okay, it's going to be fine because I'm gonna insert the last character, and then it decrements EBX, and then it increments ECX. So ECX is actually pointing to the character after the last character. So this is fine. This will insert the character at the right place. Yeah, it's a simple logic, but then sometimes it does this. It just doesn't work. It just doesn't want to work. I don't know why it does that. The order of these registers doesn't really matter, but mm, at this point, I don't know. At this point, I'm just clueless why it's not working because I broke down the logic. It's fine. So let me just pop and do it this declare the function exactly the same way I did it here. But that shouldn't change anything though. So move EBP into ESP. Yeah, that's fine. Everything is fine. It's just a really small issue that I have to really sit down and think about. Yeah, everything is fine. The register doesn't really matter. I was just testing out to see if it's going to input, if it's going to work. And here it is adding. So what's the issue? Is it the adding part or it's here? Okay, it does decrement EBX. It's working perfectly fine. It is decrementing and doing the right thing. How come it's not inserting? I honestly don't know why, because let me do this. Okay, so since it's kind of Or maybe it's ESI. Maybe I don't have a full understanding of how to use the ESI register. So what I would do is I'll use the EDI register. I'll use that as my counter, right? So instead of me incrementing here, I'll use an integer to increment. So I'm going to say ESI plus EDI, right? ESI plus EDI. And then instead of increasing ESI, I'm going to increase EDI. Or you can use EDX, whatever. Let me just make use of EDX. Thing is, I don't know what EDX wouldn't EDX be affected? I'm not sure if it would be affected. But yeah, I just made a subtle change. I think I'm not understanding the full working of it. Okay, I am, and it is working. It is fine. So yeah, either way, however you do it, I thought this surely would make it work. Yeah, it's totally refusing to do anything. So I'm just gonna put it back the way it was, so that clearly isn't the issue. And if you check in your practical, they told you to do it like that. So when you decrement this here, what's actually happening here? I'm just decrementing ECX. That's nothing. So let me choose a different approach to do the loop. Maybe that's it. So instead of moving the length of the string, what I would do is I will start my ECX at 0, right? And then just count. And then at the end of the day, I'm going to increment ECX register and then jump to for loop to start the loop. And then every time I go into the loop, I'm going to check. So compare. But before I compare, I need to move into EAX, the int length of the array. And then I compare that length of the array with ECX register. And then jump when they're equals to end loop. It's not going to change much, but I don't know. Because I'm telling you everything is fine here. 99 operands must be of the same size. Where is 99? How did I declare? Oh, remember what I said? Okay, I could just use AX register, but remember I said EAX register is meant to store D words, so I have to change that to a D word. Honestly, it was. I remember I did do this practically. It was working. I did the exact same thing, similar thing. It did work. And then now all of a sudden here it's not working. Mm, yeah, either way, in whatever way I do it, it doesn't really matter. The issue is here. That's where the main issue is. At this point, I don't know, and I can't just give you guys code that's not working. So I don't know whether I should just stop recording and then figure it out and then send you the code. Because I'm trying to understand what is the issue here. This exact part, you see this transferring the values from one array to another is the issue. But here I'm sure this is fine. So to just double check, right? Let me do this. Let me print the value inside ESI register and see if it's increasing one by one. Excuse me, if it's increasing, and then I'm gonna output, because now I'm just basically debugging now. str new line, and then after incrementing ESI, I print it out, right? So it's going to be printed out on a new line every time. So I'm just gonna have to create a smaller string. So HLL. Okay, this is going beyond. Yeah. Yeah, that's why it's not working. Now I see. It's going over and beyond. Why does it keep on going further and further? Because I only put 5 characters, so there should be, it's going to print 2 lines at a time, so there should be 10 lines. So you see, that means something ain't right, whether it's with my ESI, where I'm incrementing. What's wrong with ESI? Doesn't it like this? So let me just do the other approach. Let me say add into ESI 1. Doesn't ink work? Because ink just meant to increment and it should work. Okay, it's pretty much the same thing. Okay, let me put back the code and then, so the issue could be here. Yeah, this is way, I'm going far further beyond the memory addresses. I don't know how is it going so far? Why is it doing that? Because ESI, oh, there's 255 characters. That's why. Yeah, that's why. But even though there's 255 characters, it shouldn't go through all the characters. So let me do this. Let me make my arrays a bit smaller, just for testing purposes. I'm not sure why it's doing that. And then the array should be 5. So it's 2, 4, 6, 8, 10. Yeah, so it is fine. So that means it is using that 255, even though those are not all the characters that are there. So now I see. So in order for me to avoid this thing, right, what I'm going to do is, because it's appending yeah, it's really annoying. Do you know what it's doing? It's appending that, let me see. Okay, let me put it back. The annoying part is that it's appending, yeah, so this length of function, you see this int length, this is too big. I need to actually find the length of the array. So that, why am I doing that? So that I avoid wasting time. That's why. I don't want to 255, because remember 255 is very big. So what I'm going to go to do, I'm going to say start for loop. Okay, that one was called loop, and then I'll call this start loop. Yeah, I see why now. It might not necessarily be the issue, but I feel like it's better than this way. Let me count how many characters are actually there. So I'm looking at EBX, right? So I'm going to compare whatever is inside EBX, byte pointer, EBX, compare it to 0 or just byte pointer 0. Basically, while it's not equals to now, then you should continue adding. If it's equals to now, then jump if it's equals to now to where? To stop the loop. So when I've eventually reached now, then stop the loop. So that means I'll stop at exactly the number of characters that are there in the loop, in the string. It won't go through 255 characters, which is very long. So yeah, you needed this part. I just totally forgot to put it. So what do I need to do? I need to always jump. Okay, before I jump, remember I'm counting. I need to increment my ECX. So increment ECX and then jump to start loop. And then that's pretty much all you have to do. So it's going to increment ECX register and then jump to the start of the loop. So at the end of the day, ECX would have the size of my string. And then, yeah, there it is. Add ECX, right? And then that means, okay, that means since I'm storing the size inside ECX, I can just start comparing here. But then remember now ECX is the size. So I need to put back that other code. So I need to compare on the outside and say compare ECX to 0 and then jump when it's equals to end loop. So these two lines do not need to be here. And then here in my code, I need to decrement my ECX register. So I think now it should work. ESI register is fine. I'll leave it like that. So now it will what I simply did was calculate the length of the actual string, right? Okay, clearly doesn't want to work. What I did was calculate the length of the string. Okay, now it's just jamming. So I calculated the length of the string, right? Which is this part here. And then store it inside ECX register. And then, oh, I see my problem. I do not move to the next character inside EBX. So I need to say increment EBX, which is now, yeah, now it makes my code a bit simpler. So now EBX is actually is going to point to actually now, is going to point to now pointer. That's EBX, right? It's going to point to now pointer because in order for us to compare EBX register, it has to actually be pointing at some point to point now pointer. So since we now know that EBX will point to now pointer, I do not have to worry about ECX. And then I'm going to enter here and say um, decrement EBX because remember EBX is now when we left it, it was pointing to null pointer. So I need to point before null pointer, which is the actual string. So before null pointer, it's actually the last character. And then I think it should be fine now. So let's see, decrement, add, this can just be increment, it's fine. But let me see. This is clearly not right. Um, okay, so let me do this. I don't know what's going on with the ECX. It's a ESI register. Because like I said, we did count exactly how many characters are there. And we exit when it's equals to 0. And you can just double check to show you that it does store. I didn't want to change my code that much, so now it seems like I have to change the code. I'm changing the code over and over. What's the issue now? So EBX is the string, right? Which is fine. And then jump when it's equals to null point, when it's pointing to null. Increment ECX, increment EBX. Right, and then that's fine. Also, this part, but then it should be working. Let me remove that part. Yeah, I see it's crashing. So it does output 5. You see that it only saves the actual number of characters. Where's the output here? So we actually have the actual number, not 255. This is starting to get on my nerves now. What issues? Where's the issue here? Because I don't see any issue. Yeah, increment. Oh, let me do this. Decrement ECX. Uh, yeah, that's not the issue, but Remember, ECX will be pointing to null pointer also, so I need to decrease it to actually point to the last point, to the last index. But then I do not want to exit when it's now, okay, it's fine. I can just leave it as it is. I thought that is something to do with it. Okay, now I'm just confused why it's not working. So let me do this. So I'm gonna loop and then for loop, right? So eventually it's going to stop. So it shouldn't do anything, right? So what I'm going to do is, oh, I think I know the issue now. Let me do this. I don't know, but okay, let me put it back. And then I'm gonna go somewhere here anyway. Let me put it here just before. I want to test something here. Well, that's not the issue. I just wanted to test if I should initialize the string initially to a null pointer. Okay. Oh yeah, I need to put back that loop keyword. I've been changing my code up and down, so yeah, that's why. Okay, loop, it doesn't matter. I still decremented ECX. That's, yeah, it didn't really matter. So I'm just gonna use loop. So now it's back to where it was, right? And then here we need to initialize it to null pointer at the end. Finally, I don't know what, and it didn't change much. I don't understand why this thing does this. So yeah, now it's finally working. Like I said, the code wasn't wrong. What did I do? What did I change here? Oh, oh yeah, I simply added this code here to calculate the exact number of characters that the users entered. That's the only thing I did. So it actually didn't want you to go. Okay, pretty kind of makes sense. It didn't want you to actually go because what was happening, remember my length is 255 characters, right? So this was my string. This is the string that I was entering, right? So let's say this is a string here. You entering the string, but then there's 255 characters, so it was going, and then eventually when you get there, it put the null pointer there. So you see, it was getting confused. So actually wanted you to calculate the exact number that the exact number of characters the user has entered before you can append the null. So that's the only thing that I changed, and it just started working. So yeah, this is the code over here. You're just simply transferring the characters. The problem is, you see this part here. If you also forget this part, it's shy. Yeah, I must practice assembly more. It's been a while since I uploaded a video, and I've been neglecting assembly. And I don't really do assembly like that. I just do it when you guys need a video or whatever. So yeah, now it's working. So I'm going to say I am going to school, just a simple sentence, right? And then there you go, it does reverse the sentence and it replaces also the characters. So yeah, the code is actually working now. So the only part that I was missing is here, which is basically you use a for loop to find the exact number of characters entered by the user. So you need to get the exact number. Then you decrement because remember my EBX will be pointing to null pointer. So I need to reduce it by 1 so that it points to the actual last index. When it now points to the last index, then I start transferring the values. Then I decrement, meaning I'm moving from right to left. So that's it. See you next time if I end up uploading a video.